The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our SolidCAM Live today, 30 minutes free training. With me, as always, the state of Minnesota's strategic energy drink reserve, Kevin Rankel. That is an inside joke. He drinks too much Red Bull. Okay.
Can never have enough.
Yeah. So we actually got a question, I think it was late last night, from Brian. Let's see if Brian is in attendance. Yes, he is. So Brian's question, perfect. Yes, Brian is in attendance. Brian's question was, is there documentation on all the different 5-axis toolpaths? Yes. So if I bring up our SolidCAM website, if you go to subscription, documentation, and then under milling, you can find documentation on pretty much all of our modules, all our toolpaths, and you can see at the very bottom here, it says 5-axis simultaneous. This is a training guide as well. So I think there's some exercises in there that you can follow. You would download the PDF, and you can also download the examples, and then that gives you something to play with. On top of that, you actually have preloaded files in your, I think it's the user file inside of your SolidCAM. With each.
Before we hop to that one, for those of you guys to in-depth simultaneous 5-axis, this book right here, if we were to do on-site training of 5-axis, Mark, I, or anybody of us in the company, this would be the book that would be training you guys off of. So nice go-to parts. They do have example parts in there of ones that have already been programmed or built parts, as well as unbuilt parts, so you can follow along with that book. Now, you guys will need full access to the website, and what I mean by that is you will have to be logged in to be able to view all these files. And Mark, if you just go ahead and just log out and
well, I'll do a incognito.
There you go.
That way I don't have to log myself out because I don't remember my password. But you can always go to subscription, logins, and then if you have a login, if not, you can register.
Yep.
But there you go. So basically, once you log in, you have access to all the videos, documentation, anything that as a customer you have access to on the website that you wouldn't have otherwise without registering and logging in. And also what I was mentioning before is part of those training modules, if they're not already part of the download you get from the website, you can find them here in your own install of your versions of SolidCAM under users, public documents, SolidCAM, in this case SolidCAM 2020, and in the user folder, you can find these examples here. So user, getting started, SolidWorks, and then you've got all the different examples of all our different toolpaths, HSM, HSS, and you can see there's a couple of 5-axis ones in there as well. And that's the one I actually have open here. I've relabeled it so we can play with it a little bit, but it looks like it's just a turbine blade right there. And basically, what we'll do is we'll go through the ones that Brian pointed out in his email. We won't be able to spend any time on them really. This is only a 30-minute session, and it's like Kevin said, you definitely want to have some either on-site training or online training on these individual toolpaths. There's also KevCam videos on the YouTube channel where Kevin went through each one of these in depth for his 1-hour session. But what I want to do today is kind of do the same thing we did previously with pocket versus profile or HSS versus HSM. Just kind of talk about how you would know which one to use, because they can pretty much be applied almost to the same parts. So to get started is basically the simultaneous 5-axis toolpath is the one I want to talk about first. This is the parent toolpath to pretty much all the other ones on the list here. And that's because inside this one toolpath, you have different options to angle the tool, to select geometries. There's lots of different things you can do this one toolpath that pretty much once you align the parameters, you can do very similarly in these other ones. You can think of these other ones like the toolbox cycles, where a toolbox cycle does a specific thing like a slot or an additional slot pocket, like we did that one day with the slot, flat on a cylinder. All of those are a type of pocket or profile, but in the toolbox cycle, it's streamlined for that one application. So you can think of the same thing here. The simultaneous 5-axis toolpath can do all kinds of different 5-axis toolpaths and movements. These other ones streamline it to its specific example. So for instance, let's start with the first one here. rotary machining fourth axis. Rotary machining fourth axis is either for your 3+1 machine, your Milton machine, or even if it's for 5-axis, but you're limiting the travel to just the fourth axis. What you're doing with this is you're basically just doing it almost like a cam part. You choose your solid, so you can see here it's been defaulted to the target, but again, I can also choose all kinds of different solids. And I will tell it to either do the entire part, or I can give it a limiting of the travel. In this case, that's what I did here. I just said start at the top of the part, and then only work down as far down as this face right here. And that's only in the axial direction. Let me just turn this off. The rotary is the z-axis, so it's actually going to follow this exact shape there. Choose my tool there. Levels, very similar to what we saw with some of the 5-axis stuff. You can actually set a clearance cylinder. Now, in this case, though, because this is a 4th-axis toolpath, it defaults, and the only option is the cylinder. Toolpath parameters, very similar to what you would find in simultaneous 5-axis. In the tool axis control section, we're not actually controlling the angle. All we're doing is just telling it what the rotary happens to be. So if this was a 5-axis machine, I could set any one of those axes as the rotary and then just limit it to a rotary axis style toolpath. You could do the exact same thing in the simultaneous 5-axis toolpath. You just have to select that as an option. Whereas here, it's the only option. So again, a very bare bones version of this type of toolpath. And what this actually does is you can see it follows the shape of that solid. So if we kind of take a look at this in HostCAD, just real quick to see how the tool moves. We'll get a front view of this thing. Stock recognition was turned on. Let's turn that off. So what it's doing is actually following, I have it set to along, but I can also do across. And it basically will just go back and forth. Now, you can actually set a step down, step over. You can do this almost like a 3D recognition version of a 4th-axis toolpath. So this is very useful for these rotary style parts. You can do the same thing with the simultaneous 5-axis toolpath, but again, you have to play with the parameters to get it to do exactly what you want. Whereas here, it's very streamlined. So it does specifically this sort of movement on this kind of a part. Okay, let's look at the rest of the list here. So again, the 3 to 5-axis conversion, currently it only applies to HSM. So what you're doing with this toolpath is you create a HSM toolpath. So it's a 3D recognition toolpath for finishing or semi-finishing. But the idea here with the conversion is maybe the reach of the tool can't do the entire part. And you saw this in one of Kev's videos where he has this really tall part and he just needs to angle the tool just a bit to continue his HSM toolpath. So with the HSM conversion, what you do is you open it up, you link it to a pre-existing HSM toolpath. So if I had one, it would be in this list. And then the rest of this window is really just converting it to a 5-axis toolpath. You can get your tool axis control, and you get a limited version of the tool axis control menu than you do with the simultaneous, but you still get the ability to point the tool in certain directions or angle it based off of an axis, very similar to what we talked about previously.
And this is really
and then everything else here.
If you guys are trying to get into an area with a short stubby tool, instead of doing it in 3-axis, this will, like Mark was saying, it will convert it over, throw a little tilt angle on there, and so you can get down there with that short stubby tool.
So it's really just applying to HSM, exactly like Kevin said. Tilts the tool because of the fact that you might not have enough reach. The contour 5-axis machining is the idea that maybe you don't have surfaces either already on the part or surfaces at all that will tell you where to move your tool. Because remember, with the simultaneous 5-axis toolpath, you're choosing a surface to dictate the travel of the tool, where you'd like it to go, and in some instances, how to angle the tool. But if you don't have a surface that's really helping you with that, or maybe you want to control the axis of your tool very stringently, you want to tell it where, at what point on the surface, one point on the part, you need it to be at a particular angle. Well, with the contour 5-axis, you control everything with curves, everything with chains. And you can see in this one window here, basically what it's referring to. The red is your chain. That's your actual toolpath. And these lines represent the angle the tool is going to take at each of those points. So it's a lot of sketching, but once you put in your tilt lines, you can tell it exactly where you want it to angle. So let's say on a part, you have it set to do a particular angle relative to the rotary axis, maybe 90 degrees so that it's pointing down. Maybe you want to shift it in the Y direction a little bit. But as it goes along, there might be a pocket or a feature on the solid or even the fixture itself where the tool just needs to tilt right at that instant. Well, if you set a series of tilt lines along the part and then just the last one cocked at a certain angle so that it actually avoids that gouge, that's what this would allow you to do. You can really control point by point the angle of the tool.
And how it works with those tilt lines too is, if kind of like in the picture right there, they're only using 3 tilt lines for that one face. So what it's going to do is it's going to follow that exact tilt line, and then when it moves to the second line, it's going to be morphing the entire time until it gets to that second line and be completely in line with that one. So it's not just a quick drastic move, so as soon as it hits that line, it's automatically going to change. It's going to be doing a morphing as it's going through that.
Yep. Okay, so further down the list, multi-axis drilling, you can kind of do that with the simultaneous 5-axis as well, but this one is actually pretty useful on its own because rather than setting up MAC positions or index positions for each drilled hole, this actually will recognize from your solid the different trajectories of those holes, and then it'll generate one tool path that will angle the drill for each hole. So it's actually pretty useful on its own. But it's included in this list here. We'll touch base on it for a second there. Swarf machining is really only for swarf cuts, only for the side of the tool following that surface. It does it in a really good way. I mean, you got all these different options to control the tilt of the tool relative to the surface you're trying to machine. But I don't even use this myself. There's very few times where I'll use this where I actually like how it works in my part, because I like to control the tool using the simultaneous 5-axis one, because there's a lot more different options in there to kind of avoid gouges and that sort of thing. This one still has a gouge check, but it's not as intuitive as the simultaneous 5-axis, if that makes sense. This one is purely for this sort of shape here, whereas if I have something that actually changes shape in the profile, I like to use the simultaneous one. But this one actually is pretty useful when you have these exact sort of side of the tool following that exact curvature there. And you define it using the same. You define it using the same thing. You just choose your surface, and then you either can define it as following the floor. So you can see there, once we choose the floor, it gives it the proper tilt. You can give it tilt lines, very similar to what we were just talking about. So you can actually generate face curves on the curve, or you draw your own lines in there, or you can do it by the upper curve and lower curve. This right here is very similar to morph between boundary curves, where you choose the upper curve and the lower curve, and then it makes sure that the tool vector passes through both of them.
Now, what I was going to say,
Kevin, you were going to say something.
This tool path works really good if you guys are doing like a 5-axis trimming. So if you had like a flat part and you were trimming off some, maybe like a plastic injection mold, or just cutting the outside of a part with, and you had some swarf edges on there, that's where this tool path really comes to shine for you guys.
Absolutely. It's one that every time someone asks about 5-axis trimming, I show this one. Also, the simultaneous one that I was talking about, because you can line up the parameters on that one to do it, but this one automatically understands you're going to use the side of the tool. And you can see here in the tool axis control section, there's not much here to really control the angle of the tool, because it's all driven by those surfaces there. So this one is purely only for side of the tool doing like Kevin said, either a trimming or you're doing some sort of swarf cut on a blade or something like that. Now, multi-axis constant step over. This is actually a new toolpath, as far as I know. I think this was introduced in what, 2019?
Yeah, 2019 or 2018, somewhere in there.
Yeah. This one is very powerful, and it can do pretty much everything the simultaneous one does, but only with a constant step over style toolpath. If you see the video on our YouTube channel, our colleague from SolidCAM India really goes through the details of how this works. And once you get these parameters lined up, it's very useful for a lot of solid-based toolpaths, because that's basically what this one's working off of. You can select surfaces, but its main focus is the solid model, and it will generate a constant step over, very similar to what you see in the hatch profile or the HSM 3D constant step over toolpath, where it starts from a center point and it just morphs its way outwards, doing an offset. This one will lay it on top of a 3D model, but it is using similar methodologies, similar parameters to the simultaneous 5-axis toolpath, but with just the idea that it's going to do it on a solid rather than surfaces, and it does it as if it's draping it in 5-axis. So you have control over the angles of the tool very similarly than the simultaneous 5-axis, but you're doing it with the idea that you're going to basically just kind of drape a toolpath. You're not choosing a direction. You're kind of just doing a concentric circle or like a spiral or something like that. He does a better job on the YouTube channel, that our colleague from India. So I can't touch too much on this one, especially since I haven't used this one often enough myself. So I don't really know the ins and outs of each of the parameters. The only thing I've ever actually done is morph between curves, or doing this one here where you can see it actually will do something like this. It will drape the toolpath in concentric offsets. In addition to the fact that it's solid based, there's a lot of gouge checking going on in there as well. So automatic tilting and all that. So I think of it as a solid based 5-axis toolpath. Now, it wasn't included in Brian's question, but screw machining is a very useful toolpath, and that was introduced, I'm going to guess probably like 2016, 2017, yep. But it actually got really improved very recently in the 2019 and 2020 versions of the software, mainly because it's such a complex toolpath, it took long to calculate, whereas now in the more recent versions, I'm not sure what the development team did, but they made it calculate much faster. It is a very powerful toolpath, very, very cool looking toolpath, because it's the same idea as the rotary machining 4th-axis toolpath, where it's going to look at your solid and generate a toolpath based off that. But the screw machining actually will follow the curvature and the shape of the screw. So you'll get concentric helical toolpaths around the screw. Yes, so Brian, so the question is, screw machining, is it related to Swiss screw machines? No. The screw machine is the idea that you're doing some sort of impeller, or a feed screw, exactly. We have many feed screw customers that are doing that. And I think I have an example of it. Let me just see if I can find it off screen here. But it is not a bad name. Well, once you see what it does, it's not necessarily a bad name. It's just a misleading name, because in our industry, a screw machine is a Swiss-style screw machine, whereas machining a screw is basically machining with a helical toolpath. I somewhat agree that it's a bad name, because I know when we tried to sell it initially, people were saying, well, we don't have a screw machine. Okay, so let me get into...
I like how he says, bad name, change it.
Well, actually, that gives us an opportunity. I don't know if we're allowed to release it, but there are some name changes coming in a future version of the software, as far as I know. I don't know if we're allowed to say that, Kevin.
No one's going to tell on us.
Where did I keep that part? So any questions in the meantime on anything we've seen so far, or anything else we've done today? Perfect. Okay, so any questions on this stuff before I leave this file on 5-axis, or how to choose between them? Basically, the topic of today is how to choose between the 5-axis toolpaths. There is a YouTube playlist relating to each of the, and I think I mentioned this once before, in the simultaneous 5-axis toolpath, in this one menu alone, each one of these has a different way to control the angle of the tool. There is a playlist on our YouTube channel where I've made a video on each one of these. And the whole thing behind the simultaneous 5-axis toolpath is this one window. You're just really just controlling the angle of the tool. All these other toolpaths we talked about today do the same thing, but with bare bones. They're basically just limited parameters. They're looking at a specific thing. So the rotating 4th-axis toolpath is doing almost like a cam follower style toolpath. The Swarf cut is literally just using the side of the tool to cut a blade, or like Kevin said, trim some plastic. There's a lot of different toolpaths in here, but the discussion is basically like we talked about with profile and pocket. You're really just trying to figure out which one is the less clicks, which one matches what it is you're trying to do with your part. It's your familiarity as well. I mean, some of these toolpaths can be really complex, but if you really know how to use them, then I can't train you any other way. If you know how to use it and you know how to use it well, then why not just use that?
Yeah, and one thing, you know, if you guys are just kind of getting started learning the simultaneous 5-axis, go ahead and get yourself familiarized with the HSS first.
Yes.
And the reason I say that is because HSS and 5-axis are identical except for the tool axis control. So get yourself comfortable with the HSS operation and then go ahead and move to the 5-axis. Now, I'm not saying you can't jump head first into the 5-axis, but it's going to make it's going to be a little bit easier on you. And I was actually down in Rochester a few weeks ago teaching 5-axis, and our first day was just going over the HSS functionality before we moved over to the 5-axis functionality. So just a little bit of way to get familiarized with it.
Yep, absolutely. It's exactly what Kevin said. Whenever I'm training someone in the online sessions, I check to see if they are familiar with HSS, and if they're not, then we start with HSS because it is exactly the same. It's just that tool axis control section. And if you think about it, the angle of the tool is not really part of the toolpath. You're just kind of angling it to avoid collisions or anything like that. The actual control in a simultaneous 5-axis toolpath or HSS is the surface and is that curve that you're staying parallel to, perpendicular to, or blending between. So Brian's just saying, go back to 2014 and tell him all that. I wish we could do that with a lot of stuff. So what I'm doing here is I'm recalculating this screw toolpath only because I brought it into 2020, but automatically it looks like it's going faster than it did back in whenever I first programmed this thing, probably 2016 or something like that.
Yeah.
And what it's going to do is, I didn't actually work through it because I wanted to generate the toolpath to show it first and then get in here, but this is also a solid-based toolpath. You tell it that this is the solid, you tell it what the stock is, in this case it's probably just bar stock, and it will generate a toolpath that follows the actual helical nature of that, that impeller blade there, or that feed screw blade. But this is automatically faster. I mean, if you were familiar with screw machining from when it first came out, it would be a joke that I would think I could calculate this in this half-hour session. Meanwhile, while I was talking, it finished.
Yeah, and what they've done with this, the multi-axis is utilize the multi-core functionality, but now if you guys notice that when Mark closes out of a part file right now, you'll see the zipping or opening up a file, unzipping of that file. What we've done is completely changed up the geometry tags to make things a whole lot faster for your guys' programming experience. And if you guys are running a older program that is running slow, I know this kind of sidetracks you, Mark, but can you just show the show that in the CAM tree where we can change? Right.
Sorry, show what?
Do the new geometry tags. So if you guys right-click on CAM part and then go down to the optimized geometry database. Now, Mark had this part already converted, so it's done. But if you guys are running any older files and are noticing some slower speed, click that, and what it will do is it will convert the tags over, not losing any geometry, but it will be a much faster experience going forward. So, sorry.
Yeah, no, it's a good point, because going from older files to newer files, this is something that was introduced, again, I can't remember if it was like the previous version or the one before it, but it's exactly like Kevin describes. What it does is all those geometry tags, all that geometry that's being referenced throughout the toolpaths, throughout the file itself, that's sometimes the thing that can really slow it down, where nothing's in order. Basically what this is doing is just kind of reducing the look for kind of thing. If you think of it, it's almost like the defrag on your computer. Your computer currently does it by automatically, but older versions of Windows would require you to periodically defrag your computer and eliminate any of those open spaces between different files and stuff like that. So this is the same thing. It's really just kind of shrinking the file down and making the ID tags sequential, so it's easier to reference things, your associativity and all that kind of stuff. And the newer versions of SolidCAM have that preloaded. So I can see it here, but like Kevin said, this one automatically optimized it for us as soon as I opened up the file. But screw machining is a really cool toolpath because you can see that it actually is following the exact shape of that feed screw. So I have this set to roughing, although you can do finishing as well. And I have it set to offset, although you can do offset and spiral. So instead of just doing a simple offset, like you can see there where it's doing this turn around here, I can actually get it to spiral around certain areas and then do a little bit of this offset. And it is a solid recognition toolpath. It's a rotary toolpath. It's still moving around. You can see that it's still actually moving around the rotary, but it actually allows me to choose a solid, or I could have defaulted it to the target. And I can give it axial limits, radial limits, so I can tell it how far along the axis, the rotary axis, or I can limit the travel to a certain pi slice of the radial. So I have the ability to kind of limit the travel of the tool if I'm only looking to do certain things. The tool selection is very much similar to what you saw with all the other toolpaths. Levels, it actually grays it out. It defaults it to a clearance cylinder, and it's reading it off the solid. Toolpath parameters, you give it a constant step down, or you can give it a maximum step down. Sorting, you can do pretty much all the same sort of stuff you can do in the simultaneous 5-axis toolpath. Again, this is just really bare bones. And then you can define your stock either by a bounding cylinder, basically just kind of like that cylinder definition you usually get, or I can do it by updated stock, which is very good if you're doing a conical feed screw or anything that has that conical shape. Because now, instead of trying to do just a constant diameter, it actually will read and trim out the air cuts. Tool axis control, this is purely a rotary toolpath. So I really only have the ability to choose my rotary axis and maybe a base point. So there's nothing here about angling the tool, but it will move in the radial direction. It will move in this case, the y-axis. So it actually does have that side shift. So this is purely a 3+1 style toolpath. I'm seeing there's a question here. So, okay, so Brad's question is, with this screw machining, can 3D eye machining be used by rotating it every 90 degrees? Would it be a good idea? It's rough. Yes, that's a good question, and that is actually a good strategy. If you have a 3D recognition toolpath, if you have 3D eye machining, then it's not a bad idea to basically put a bunch of indexed angles, maybe 0 degrees and 180 if you can reach. If not, maybe every 90 degrees, like Brad just suggested. That is what I would show people before this toolpath came along, or before, to be honest, before this toolpath calculated this fast. Eye machining is always a good idea. Now, right now, we don't have a rotary version of eye machining. We don't have a rotary screw machining, but it is a great way to reduce your cycle time and machine out a 3D solid. I mean, if you think about it, this thing, if you don't look at it as a rotary part, all we have to do is just have an index angle, and then we can rough out all that stuff and then come in with a nice simultaneous 5-axis toolpath, maybe a Swarf toolpath, something like that. The purpose of the screw machine, at least in my opinion, is to get this shape here. It follows this exact thing automatically. So if you don't have eye machining, you don't want to do a wrapped geometry of eye machining or anything like that, this is a great way to do this sort of toolpath because it's a recognition toolpath. Anytime there's a recognition function to a toolpath, I'm going to go towards that sometimes more than I go towards eye machining. Because a lot of times, especially with these screw machine manufacturers, cycle time is not their biggest thing. They have these massive parts where as long as the code is good, they've tested it out, they simulated whatever. Now when they go to produce these things, they let it run overnight. So cycle time is not the biggest deal with these guys. So eye machining, as great as it is, sometimes they need this accuracy here of actually how they're going to finish the walls and all that. This is a really good toolpath. I like this one. So this one actually, in my mind, is in competition to indexing a 3D eye machining. That being said, always remember, and this is, I mean, we're near at the end of today's session, but anytime you're doing a part like this, if it has a cylindrical core, anytime you can do a wrapped part, you can still do eye machining with wrapped geometry. So let's say we do 2D eye machining, and I don't have eye machining defined on this part. So let me just get that in there real quick here. So again, I'm just going to pick stuff at random. But with your profile, your pocket, and especially 2D eye machining, you can choose wrapped geometry. So let's say we ignore these guys here and just go with the old school here. If I click new geometry, I always have the ability to do a wrapped. And if I wrap my geometry around the x-axis, I can get 2D eye machining, the same sort of tricoidal toolpath, D-slot tricoidal, the controlling of the tool, all that stuff we get and benefit from in 2D, we can get that to wrap around the core. So as long as it's purely cylindrical and has a constant radius across the thing like that, you can do wrapped 2D eye machining. And that is kind of the bridging of what Brad is asking about and this screw machining. You're still going to get the movement of the tool doing the tricoidal stuff, but you'll get it in a wrapped toolpath, if that makes sense.
Yep. And the nice thing about the screw machining is you'll get on that hub of that feed screw right there, you'll get a really nice looking finish on there. So when you go to do that finish pass, I've seen a couple parts come off with that, and you really get some, you know, if it's something that it's going to be visually seen, you will get some really nice outcomes of that.
So in the minute or two we have left, or I guess we're at the end of the session, but I don't want to mention this without actually doing it. So this is, I'm just going to do a simple pocket. Maybe I'm just cleaning the top of this, I guess it would be called a flight. And if we set this to all open edges, so that is wrap geometry. Let's just add a tool. So this tool probably will do. As soon as it's wrapped geometry, it actually will read it as radial values. So I can click on there. Let's see, try that again. I'm not sure if that is the radius, but that should be reading it as the radial value in the Z direction. And then in my pocket direction, set to 0, because I'm really just going on that top face there. Technology Wizard, all of this is still the same. We're still doing 2D eye machining. Save and calculate. And while this is calculating, and I see that Edwin is asking for exactly what I'm doing. So hopefully this is what you're asking for. I'm actually going to do the wrap geometry. So this is 2D eye machining wrapped around the core. Now it's giving us our islands and that sort of thing like it normally does. If I didn't have such a weird pocket, it might actually be continuous movements, but that is our eye machining right there.
And if Mark wanted to, he could click on that bottom hub and create those feed screws as the island per se, and it would machine out everything, all the blades in there, roughing it out as well. But
oh yeah, no, I chose something really simple because I didn't want to have to like do individual islands and stuff. But yes, you could actually do this core right here instead of with the screw machining. I could have done it as a 2D eye machining. That's why I bring it up, because there's some depth here. So you can see from the screw machining, I actually have to do some depth cuts there, multiple depths. Whereas with our eye machining, you know, as soon as there's depth, you're going to benefit.
Yeah, and maybe we can show that tomorrow.
Yeah, I should work on this part and probably show that tomorrow, how we would do eye machining on this and screw machining in general. We can talk a little bit about it a little more as well. And Brad agrees. Okay, so we'll do exactly that tomorrow. But I want to get to Edwin's question there. So do I need a 4th or 5th axis post to get this toolpath? For the wrapped option in your 2D, your pocket profile and 2D eye machining, I think your post at least needs to recognize that you have the ability to do wrap geometry. I don't think it necessarily has to be a 4th or 5th axis simultaneous toolpath. I think that's a different module. But it's best on that sort of a question to ask your salesperson, because the way we actually do the different posts, the different modules, that's not usually a technical thing. It's more of a sales-related function. So you can see how things are modularized with our software. But tomorrow we'll do the screw machining. I'll use this same part and I'll do a bunch of wrapped stuff on there. I can show you how to do, we do wrapped profile, wrapped pocket, wrapped 2DI machining, and then we can take a look at screw machining a little bit more, maybe roughing and finishing. Screw machining is a great toolpath. So if you already have access to it, try playing around with it. It's actually pretty simple to use because of how limited the parameters are, limited in that it's not asking for too much. It's much more of a recognition toolpath. And the name, it's kind of like Brian said, the name's a little bit of a misnomer. It doesn't mean you need a Swiss screw machine to do it. It just applies to a screw type geometry. But even then, you can do it on, let's say, that part we were looking at previously. It doesn't have to have a screw shape to it. It just means it's going to want to generate a helical toolpath. So rather than call it something like helical machining, and then that throws us for a loop as well, it's basically screw, like a helix around a core. But we'll leave it there because we're a little over time, and we can easily do this tomorrow. We'll go in more depth. If you have any other questions, Kevin's going to put my email in the chat section, and you can email me with other questions for the week, for next week. If we get enough of a feedback, again, use that email to give us feedback if you want more of these sessions. If you're looking for personalized training, you can always use that email again. You can use Kevin's email, and email us for a day and time that you're looking for your personalized session. We can get into a go-to meeting just like this, work on your exact parts, work on your exact questions, live over the phone as well. So you can ask questions live with your voice. And as always, if you know anybody that could benefit from SolidCAM, let us know. There's a finder's fee, like Kevin mentioned yesterday. Actually, it looks like there's an increase to that because of the SolidCAM Live and the KevCam sessions. So you can get, what is it, $100? $100
Yep.
100 US. Remember that if anyone is Canada, but I guess no one else from Canada on here. But yes, so $100 cash for just getting someone into a demo with us. So contact your local salesperson if you have anybody that would be interested. And we will talk tomorrow, 2 p.m. Eastern time. Stay safe, keep your family safe. Talk to you tomorrow.
See you guys. Bye-bye.